In section 2, we're continuing our study of chapter 1, where we're looking at the vocabulary of statistics. But in this section, we're going to talk about the different types of data that we can collect. So let's just remind ourselves, we talked in the last section about populations and samples. We said population was collecting data on every single person or object we could possibly collect data from. And then we said that populations were usually too large and it was unrealistic to collect data from everybody or everything. So we generally collect information from samples, and we'll see as we move forward, how do we use the sample to help us gauge information about the population. We'll try to draw inferences about the smaller sample to help us describe the whole group, which is the population. Now, we have more terms that are related to these two words, the population and sample. If by chance you do have access to every single thing in a whole population, so say that you did have access to DataTel and you could collect every single student's at Wake Tech's age, if you did that and you calculated the average age of all Wake Tech students, we would call that calculated number a parameter. So a parameter is any value that is calculated based on the entire population's data set. Another example is, say that you work at a company and y'all just hired 10 new employees. If you look at the average salary of all 10 new employees, that would be a parameter because you have information about everybody. In this case, it was everybody that just got hired, and you're calculating a value about every single data point. So what's nice is that parameter and population both start with P. So we have some nice alliteration to help you remember that they go together. So generally, we don't calculate parameters. It's nice when we can, but generally we're collecting data from a sample. So if we collect data from a sample, we call that calculated value a statistic. So if I were to get every single student's in this class age and average all of your ages together, our average age would be considered a statistic because it was information gathered from a sample. So statistic and sample, they both start with S, just like parameter and population, some more alliteration, but a statistic is any value that is calculated based on a sample. And as we start our descriptive statistics in chapter 3, we'll see that we tend to use different symbols to designate when we're talking about a parameter versus when we're talking about a statistic, so that whoever we're conveying our information to can easily understand, was this everybody or was this a smaller sample? So when we collect data, one type of data that we can calculate or collect is quantitative data. And I remember this by looking at the root word of quantitative, which is quantity. So quantitative data is when we're counting or measuring. We're getting the quantity of something. So quantitative data is generally numerical data, but do be careful because just because something's a number, it doesn't make it quantitative. And I'll give an example of that here in just a second. But generally, quantitative data is numerical and is when we're counting or measuring something. So like seeing how old somebody is, or how much something weighs, or what body temperature somebody has. Those are all numerical measurements where you're either counting age or measuring the weight or measuring the temperature. In contrast, we also have categorical data, which is often called qualitative data. And the root word of qualitative is quality. And so this is when we're describing a quality or a characteristic of something. And generally, these are words or verbal attributes, but not always. Sometimes they can be numbers that are not counting or measuring. So examples of verbal responses would be, what is your major? You say, I'm a math major, or I'm an English major. Hometown, you tell the city's name where you're from. Eye color, again, blue, green, brown, whatever it is. An example of categorical data that is numerical would be something like describing what type of Ford truck you have. You could get a F-150 or a 250 or a 350, but those denote whether they're half-ton trucks or three-quarter-ton trucks or one-ton trucks. They're not counting or measuring something specific about the truck. So even though there are numbers, because it's not counting or measuring, it would still be considered categorical data, not quantitative data. Another example would be something like a phone number. When you were assigned your phone number, it wasn't counting how many phone numbers came before you. It was just a semi-arbitrarily assigned number to you. I know there's a little bit of structure with phone numbers where the zip code tells what part of the country you're in, and then at least it used to be that the first 3 digits were kind of what region within a county, but I'm not sure they're that specific anymore. But regardless, phone numbers are not counting or measuring anything. They're just describing the sequence of button pushings somebody has to push on their phone to get your phone to ring. So again, categorical or quantitative data is describing, it is not counting or measuring. So within the quantitative data, which is generally what we work with because we can do math with numbers, we like math. It's hard to do math with words. So with quantitative data, we can further distinguish it with discrete and continuous data types. So discrete and continuous are subsets of quantitative data. So discrete data is whenever we have a finite number of choices for our data. Mathematically, we say that the number of choices is finite or countable, meaning we have a limited number. So say you go to Target to buy a new pair of shoes. When you go to Target, you can buy a size 7, a 7.5, an 8, an 8.5, and so on. You can't go to Target and buy a 7.9925 shoe. It is impossible. You have a set number of choices and you have to buy the shoe that best fits your foot. Or if we're counting the number of times we have to toss a coin before we get a tail, we might get a tail on the first flip, so that'd be 1, or we might get 4 heads and then a tail, so that would be 5 flips to get a tail, but you cannot flip a coin 2.5 times. That doesn't make any sense. So with discrete data, we have a limited number of choices that it could be. Typically, they're whole numbers, sometimes fractions like with shoe sizes, but they're not any number. We're limited in what they could be. And in contrast, we also have continuous data, which is when it could be any number on a range of values. We say there's an infinite number of possibilities, or it is not countable. So think about the arm span of high school seniors. If you stretch your arms out, you might have a 5-foot reach, or you might have a 6-foot reach, or you could have any number between 5 and 6 feet. Someone could have a 5.25 foot reach, or someone could have a 5 foot 8 inches or 5 foot 8.222 inches arm reach. It could be anywhere on a spectrum. Or if you're measuring height, babies start off generally around 20 inches or so, and you grow gradually, hitting all of the possible values until you reach your final adult height. You're generally around 5 or 6 feet tall. So continuous data is when we have a range of values, and it could be any number on the spectrum, whereas discrete data, we have a finite number of choices. It cannot be any number we think of.